You are looking at the screen of a Pentium PC running Windows 95 and the Netscape Navigator web browser. Within the browser, we are running the PARC Webwriter 2 editor, a system that supports the development of web applications. Webwriter allows the user to build an application as a stack of pages. Each page can contain text, images, buttons, and other form elements, as well as content computed on the fly by executing a script. This editor is based on the Meteor shower application architecture. In this architecture, operations that need high interactive speed are done in the web browser using JavaScript, while the server executes only those operations that need server resources. The Webwriter Editor has a top-level window and 5 frames that tile that window. The top-level window contains the frame set, which is a specification of where the 5 frames should be placed and what files should be loaded into each one initially. It also contains JavaScript functions that are of use to several frames and data structures representing the state of the editing session. The title frame holds the Webwriter logo. The preview frame on the left side shows the HTML page under construction. The toolbar provides file and stack operations and cut, copy, and paste buttons. The control panel contains controls for inserting HTML elements. Finally, the object property frame allows the user to fill or change the properties of an HTML object. Let's start a typical session with the Webwriter 2 editor. We can start the editor by clicking on a link. This causes our browser to call a CGI script at the server. The server-side script creates an HTML page that includes JavaScript functions, calls to build JavaScript data structures, and a frame set. When the browser receives this page, it runs the JavaScript function definitions and creates the editor data structures. Then it creates the 5 frames and requests from the server the content of each frame, starting a Meteor shower of HTML pages from the server to the browser. First it loads the title frame, then the toolbar, the preview area, the control panel, and an empty property editor. The HTML pages that are sent during this Meteor shower can be static HTML, such as the one used in the title frame, or can include JavaScript code, as is done in the toolbar, the control panel, and the preview area. Pages with JavaScript code can collaborate with one another via the editor data structures and the JavaScript functions available in the top-level window. To demonstrate the Webwriter HTML editor, we will load an existing file and make some changes to it. File loading is an example of an operation that requires the help of the server. We access the server for this operation because files are located in a server-accessible file system. We click on Load, starting a JavaScript program that displays a dialog box where we can type a file name or URL. When we click the OK button, the URL entered by the user is sent to a CGI script on the server. The server reads and parses the file specified by the URL and sends a new frame set that contains the file contents as a data structure in the top-level window. In the preview frame, all Webwriter objects are displayed and surrounded by handles, such as this icon. Handles allow the user to select an object for cut and paste, movement, or to edit its properties. Red handles indicate a selected object, while gray handles are used for non-selected objects. The blinking bar next to the handle is the insertion point. When the cursor is over the handle of an object, the browser shows the type of that object in the browser's message area. In this case, we see that this object is an address, and this object is text. Making a new selection or changing the position of the insertion point are extremely common operations when editing a document, and thus should be performed as quickly as possible. Clicking on a handle simultaneously selects it and deselects the old selection. To avoid having to reload the entire preview frame, we made use of the feature of the Netscape browser of being able to replace images of the same size in place without a reload. This allows the highlighting to occur with no perceivable time lag. The technique for displaying the insertion point also benefited from this technology. When the user clicks on a handle, that handle and its companion handle are replaced by red handles. In addition, one of those handles has a small bar next to it indicating the position of the insertion point. To make the insertion point more visible and also more like a traditional text editing cursor, we use animated GIFs to make the insertion point blink. Here we show a slow motion version of this effect. This is one of the only tasteful uses we've seen of blinking on a web page. To preview the final appearance of the page, we can hide the handles. But we will show the handles for now as we continue editing. Let's describe what's happening behind the scenes when we change the URL of an image in this document. First, we select the image by clicking one of its handles. When we do this, a JavaScript function replaces those handles with red ones that include the blinking insertion point, changes the previously selected handle to gray, and updates the global structures to reflect the new selection. All these operations are done in the client using JavaScript. Next, the JavaScript code loads into the object property frame the appropriate HTML file for editing the properties of the selected object. Most of the time, this HTML file will be in the cache of the browser, so it won't require a server access. Finally, we change the image object's properties. While some objects require a customized property dialog, the one we are using for image objects is generic, computing its fields automatically from HTML. In the image dialog area, we can change the URL. We click on Done, and the desired new image appears. Note that when we click on Done, the object property form for an image modifies the document data structure, reloads the preview area, and replaces itself with an empty HTML page. In addition to enhancing responsiveness, the use of multiple frames makes the editor more usable in other ways. Since reloading a frame usually causes it to become blank before the new page is displayed, the frames which do not change provide continuity of context. The editor behaves more like a standard desktop application which has selective control over what changes in the interface. In addition, placing the preview area in its own frame allows long documents to be scrolled without affecting the layout of the other controls in the interface. From an implementation point of view, segmenting the interface into frames modularizes the program. Each possible state of a frame is a JavaScript-enhanced HTML file. As illustrated in previous sections, active modules communicate with one another via global data and cause other modules to be loaded and unloaded into the interface. The PARC Webwriter 2 editor, an editor for HTML-based applications, is designed to get good interactive speed, reduce server load, and reduce screen clutter by using a combination of CGI scripts and client-side JavaScript. The server downloads to the browser a parsed version of the HTML page to be edited. The browser executes JavaScript code to handle editing operations on that page. The JavaScript code itself is structured according to the editor's frame-based interface, which divides the screen into areas for previewing the page and holding control panels. One or more JavaScript-enhanced HTML modules correspond to each frame. They are downloaded when needed. Updating the screen after a user action often requires only redisplaying a subpart of the window, such as a frame or a GIF image. The server is only used for fetching and saving files, parsing HTML, and starting up the system.